Hi, welcome to another episode of Algebra in Words. We're continuing our discussion on the exponent rules with variables and bases. In previous episodes, we looked at the product rule, or what you do with the exponents when you multiply bases that are common. In this episode, we're kind of looking at the opposite, division of common bases. All right, and this is often known as the quotient rule for exponents. If you want to follow along with what we're going to go over in this video in the written form, you can read along with it in my book, Algebra in Words, which you can find in Amazon, and the link to that is in the description box below. So let's get started. I have 4 problems on the board. They're all in increasing difficulty, and I all have them set up in this chronological order to serve a certain purpose for each one. So anyway, let's just review the rule for the quotient rule. What does that mean? It means when you're dividing a variable of a common base, what do you do to the exponents? You do the top exponent minus the bottom exponent. And it's as simple as that. What you want to also be aware of as you go along is to be conscious of the sign, whether the signs of the exponents are negative or positive, or whether they become negative or positive when you subtract or do a minus of a negative. We'll look at examples of all of those. So let's start with the first one, where we have x to the power of 11 over x to the 4th. And what I'm going to do is, first we want to say, is the x and the x a common base? Yes, they're both x. So I'm going to start by writing the common base x, and as the intermediate step, I'm going to just show in written form what we're doing. Top exponent minus the bottom exponent. The top exponent is 11. The bottom is 4. So we're going to do 11 minus 4. And that equals 7. So the answer is x to the 7th. And that's it. Okay, let's look at the next one. We have x to the 5th over x to the negative 3. Now, you probably noticed that now we have a negative exponent in the bottom, in the denominator, and that's fine. We're going to apply the same principle as we just did. Try not to overthink it. We're going to do the common base x, and now we're going to do the top exponent 5 minus the bottom exponent, which is negative 3. Okay, and now that means that we have 5 minus a negative 3, which, if you combine them, makes plus 3. And if I could put the answer down here, 5 plus 3 is 8. So the answer is x to the 8th. And that's all there is to it. Let's take a look at the next one. And the next one is chosen because there's a negative exponent in the numerator and the denominator. Once again, the base x is the same, so we can apply the quotient rule. And for starters, at least when you're beginning this process, don't be afraid to write out all the steps. So we're going to write base x, negative 4, that's the top exponent, minus the bottom exponent, which is negative 6. So minus negative 6. And minus a negative makes positive 6. So it now becomes negative 4 plus 6. And negative 4 plus 6 is positive 2. So the answer is x to the positive 2. And now let's look at the 4th question. This one is chosen for 2 reasons. One, it's got coefficients in the top and bottom, unlike the previous examples. Also, now there's 2 variables in the top and bottom, an x and a y. When you have a mix of these, all I advise you to do is to just go from left to right and focus on one base, common base or variable at a time. So let's start with the 12 over 6. And believe it or not, there's a lot of important information here. First of all, when you have just a coefficient over a coefficient, or a number over a number, just simplify them like normal. So for example, 12 over 6 reduces to 2 over 1, and I'm going to write the over 1 for now, but you don't have to write the over 1. But secondly, I want you to also ask yourself a question. Are 12 and 6 a common base? They're not a common base. They're both numbers, but they're not a common base. So the rules of exponents, the quotient rule of exponents does not apply to them because these are not a common base. They're different numbers. If it was, say, 6 cubed over 6 squared, now these are a common base of 6, and we could do 6 to the 3 minus 2 to get 6 to the 1, or we would just leave that as 6. So if that were the case, the numbers are a common base. But in this situation, they're not. So back to the problem. We did the coefficients first, and now we're just going to focus on the x variables. And the x over x, they are a common base. We have x to the fifth in the top, and we have x to the unwritten exponent of 1 in the bottom. Even though it's not written 1, you always want to remember that when it's unwritten, it's meant to be 1. So for the x's, let's do x to the 5 minus 1. And we know that that's going to be 4, but let's write that 4 in the next step. In the meantime, let's now focus on the y terms. And if we look at the y terms, they are, again, common bases amongst themselves. So we're going to write common base y, and we're going to do 3 from the top minus this 3 in the bottom. And now let's write equals and write what we can simplify in the next line. We keep the 2 from here. I'm not going to write over 1. And now 5 minus 1 is 4. So we have x to the 4th. And then we have 3 minus 3 is y to the 0. And for now, I'm going to write y to the 0. The reason why I'm writing y to the 0 is just to make sure that we see each step. And if I rewrite this, 2, x to the 4th, and what is y to the 0, or any base to the 0? It's 1. So this part becomes 1. Just a factor of 1. Do you need to write the 1? No, but I'm just writing it to show what it actually becomes. So ultimately, we don't have to write the factor 1, because 1 times 2 stays 2. And the final answer to this is 2x to the 4th. Now, that's pretty much it for the little lesson on the quotient rule. But before I end the video, I just want to point out one more thing. It's a question students sometimes have. And the question is, when you do the top exponent minus the bottom exponent, where do you write the result? And the answer to that is, you write it in the numerator. So notice for when we did this one, 5 minus negative 3. That stayed in the numerator, and I wrote it below, but it became, think of it as x to the 8 over 1. This is in the numerator. But let's come down to this one. And again, notice where we had x to the 5 minus 1. We wrote that in the numerator. It stays in the numerator. And then for the y, we had 3 minus 3. We wrote that in the numerator as well. So when you do those little mini calculations and the little subtraction, do that in the numerator. Now sometimes you can, and I'll put a problem up that exemplifies this, but sometimes you can, once you do the subtraction, you might end up with something like this. X to the, let's say, negative 3 in the numerator. So if we think of this as over 1 in the numerator. That's fine. However, this opens the door to another topic, which is negative exponents. I'm going to focus a video specifically on negative exponents, but for now, it's no secret. What do you do to a negative exponent? Well, normally we want to report all answers with positive exponents. So to get rid of a negative exponent, you move it to the opposite part of the fraction and change the sign of the exponent. So in this case, this would simplify to 1 over x cubed. And the point to me showing that is, always do the subtraction of the base in the numerator, but if you end up with a base to a negative exponent, it may ultimately move to the denominator, but basically I recommend you do that step at the end. Alright, so that concludes this video, and I hope you found it helpful. If you did, please give a thumbs up. Please subscribe to the channel so you can be aware when new videos come out. Please leave comments for feedback, and also be sure to check out my other videos on Facebook and Instagram. That concludes the topic of the quotient rule. In the next video, we're going to be looking at taking a power to a power, including distributing an exponent through a group.